Alright, so once again, guys, this works because if you think of, okay, the large tray is Y, the smaller tray is X, then I know that this amount, Y, plus this amount, plus this amount, plus this amount, in other words, Y plus 3 X's equals 109, right? But the second part of the problem tells us that she makes one small tray, so that would be 1X, and 2 large trays, so that's
it. You just have to write
2Y.
Yeah.
And then that's going to have a total of 128. So
But that's so simple.
2Y plus X equals 128. Okay. Now, all right, guys. So the first step is you have to know what equations you can write in order to solve this. So this is the system of equations that we could use to solve and figure out how many cookies exactly would have to be on the large trays and small. If all I had was the first expression, then you could have, you could put more cookies on this tray. You could have the large tray have, 100 cookies, and then just have 3 cookies each on the small trays, and that would be one possible solution, right? But we need a solution that works for both, which is there's only going to be one of, right? So that's why we need the system of equations, because there's infinite solutions, not really infinite just because of the fact that we have to have a whole number of cookies and not negative numbers of cookies, but a lot of possible solutions to this, a lot of different possible solutions to this, but only one that solves both. So, how would you like to solve this one? Elimination. All right. Well, let's look at, I heard elimination first, so we'll look at that one first. Now, if we have, guys, if you don't know how we eliminate with this, then you should probably listen because I'm about to show you. Rather than asking loudly, how do we eliminate with this? Just listen. I'm going to show you. And take notes. Alright, so our two equations are 1y plus 3x equals 109 and 2y plus x equals 128. Now, the problem with this for elimination is what? Nothing matches up, right? I have 1y here and I have 2y there. And I have 3x here and I have x. Now, there's a really easy way to fix this.
Oh, I know how.
Sam?
So you take one away from one problem and move it to the other problem to even it out.
No, you can't do that because that would be changing the equation. Now, guys, we can change one of the equations by multiplying. As long as you multiply both sides of the equation by the same thing, you can always change an equation. So, this is 2y, so ideally I would like for this to be
3y. 3y.
Well, not 2y, but
3, 0, 1,
negative 2y.
Dang it.
Remember, with elimination, we prefer to have opposite signs. So, guys, you know what? Do you just want to just study on your own? Because y'all keep talking, and my voice is getting dried out and my throat's hurting, and so I'm not going to yell over you all class. So if you want to continue having a conversation, then you can just study for the test on your own. Because I'm not going to yell over you for the remainder of the class period. I'm done. Stop having your little side conversations. Be quiet and listen, or you can just have the remainder of time to study on your own quietly. Am I clear? All right. So, we need one of our coefficients to be the same, which means I either want my y to both have a coefficient of 2, or really I'd like one of them to be negative 2 and the other one to be positive 2. Or I can have my x's both have a coefficient of
What, 3?
3 and negative 3, right? So you can do it either way. So let's say I want to get rid of my y's. So I'm going to take this equation here and I'm going to multiply it by what? Negative 2. Because I want to have negative 2y and I currently have 1y. So that means I need to multiply it by negative 2. And I can do that as long as I multiply everything else by negative 2, right? Remember, the nice thing about equations is as long as you do the same thing to both sides, then it's always going to be fine. Alright, so this will give me negative 2y minus 6x equals negative 218. Right? Everyone with me so far? Now, that equation and the other equation, 2y plus x equals 128, you can add together and eliminate your y terms. Those go away. Negative 6x and positive 1x gives us negative 5x. And negative 218 and 128. Somebody do that one in their calculator. I'm too lazy right now. 90, isn't it? Negative 90. Is that right? Negative 90?
Sure. Yes.
Alright, negative 90. And then we'd have to divide through by negative 5 on both sides, which gives us x equals 18. So if x equals 18, we can plug that into this equation here. So I get 2y plus 18 equals 128. So 2y would equal 110. So y would equal 55 if I solve that through. So there's our solution. The small tray holds 18 cookies. The large tray holds 55. Alright, now you could also solve this by substitution, and if you really wanted to, you could solve by graphing, but your graph would have to go out to x being 18 and y being 55, so that would be a really big graph. This is this is one of the reasons why solving by graphing, even though it's easy when it's, you know, all set up for you, is not always the best option. Alright, other questions? Cameron?
12.
Number 12. So this one here, we're going to solve now. This is important because on the computer, on the test mods, it just checked whether you had the correct solutions. Obviously on the test tomorrow, it won't be on test mods. I'm going to hand grade it because I have to check that you're using the correct method. Because I need to know that you know how to solve a system both by graphing, by by substitution and by elimination. So make sure you read the instructions and use the method that's that you're supposed to. All right, guys. So for this one, there's basically 3 steps to substitution. The first step is one of the equations needs to be in y equals something or x equals something form. Now, a lot of the times, though, that first step will be done for you. Because if you look, this has that equation, which already says y equals something, right? So, the first step's already done for us, which means we skip straight to the second step, which is you replace that value, in this case it was y. So we're going to replace y in the other equation. Now, The other equation is 6x plus 2y equals 20. But where y is, I'm going to replace it with 2x because y equals 2x.
Yeah.
If the two things are equal, I can replace one with the other, right?
Yes.
So I'm going to put in 2x here where my y was. And then it's just simplifying. 2 times 2x is 4x, so I get 6x plus 4x. And then that gives us 10x, which is 20. And then if I divide through by 10, yeah, that'd be good. And then if I divide through by 10, we get x equals 2. So that's the first part of my solution. And then I just take one of the equations, y equals 2x is probably the best choice, and replace x with what x equals, which now is 2. So I get y equals 4. So my solution is 2, 4. So like I said, 3 steps to substitution. First, get one of the equations to say either y equals or x equals. Then whatever you get, like if I get y equals, then I'm going to look at the other equation, and where I see y, I'm going to replace it with what y equals from the other equation.
Wow. Or what x equals.
And then I'm going to simplify that down to find out what the other variable is. Guys. All right. Zach.
Number 10.
There's no number 40.
10 was easy. You just
I got
grabbed
30.
10.
All right. Number 10.
Yeah, number 10.
All right. This one is solved by graphing. So, in order to solve this by graphing, the one that's easiest to graph is
Y plus x equals -1.
well, I'd say, guys,
It'd be the bottom one.
the bottom one's easiest to graph because it's already in. Right. So, my y-intercept is 2. My slope is 1/2, so I rise 1 and run 2. Now, one thing I did see as people were working on this yesterday, I saw people getting the wrong solution because their lines weren't straight. You've got to make sure your lines are straight. You've got to make sure your slope stays the same. So one thing that you can do is instead of just graphing one point using the slope, graph a couple. So, up 1 into the right 2 or down 1 into the left 2. I get the same line.
And then do it like 9 times.
And then do it as many times as will fit on the graph that you have. And then connect those points.
Can you wait? I thought you had rulers, like a lot of them.
I do have rulers, but even with rulers, sometimes if you don't line up, like sometimes people when they're connecting their dots will get their ruler like below the points instead of right on them, and it'll still mess up. So that's why I say, it's a good idea to make sure you're connecting more than just a couple of points. But then, yes, then after that, you do want a ruler or a straight edge of some sort to connect them. All right, then we have a second point to graph, or a second line to graph. Barrett, Brian, eyes up here, please. Now, the second one we have to graph is y plus x equals -1. Now, you can do 2 different things here. You can either take that equation and just subtract x over, and then you get y equals -x minus 1. So we have slope-intercept form, and graph it. Or you can make a t-table and just pick some x values, like let x's be 0. So y plus 0 equals -1, so y would equal -1. And then you can say y plus 1 is -1, so y would have to be -2. So you can plug in points that way. Either way will get you the exact same line. So it's up to you. I personally am a big fan of slope-intercept form, so that's the way I would do it, but either way will work the same. So then I've got a slope of -1. So I get this, and as I'm drawing my line, I can see that there's going to be that point right here, which is where the two lines cross. So my solution is -2, 1. All right, Hannah.
Wait, I don't. Oh yeah, I get number 2.
All right, number 2. All right, guys. Let's look at number 17. Now this one, guys, this one you could solve using any of the 3 methods. So you could solve it by elimination, or by graphing, or by substitution. It is completely up to you which way. So, Cameron, how would you like to solve it?
Elimination.
Okay, so Cameron wants to solve it by elimination. Now, if we look at this with elimination, we have y equals 2x plus 1, and we have y equals 2x plus 3. So I've got positive 1y and positive 1y, and I have positive 2x and positive 2x. So I'm going to multiply one of these through by -1. So I'm just going to do that to the first one. So that would give me -y equals -2x minus 1. So I'm just rewriting that one, multiplying through by -1. Everyone with me so far?
Totally.
Okay. Now I can add them, and I get y plus -y, which is y plus -y is
Equals
Y
zero.
plus
Is 0.
Sure.
And then I have 2x minus 2x, which is 0, and 3 plus -1, which is 3 plus -1 is
3 plus -1 is
Negative 2.
all right. Now, we did not specifically go over any examples like this because of the fact that IXL didn't have any examples like this. But we have done this before
we have.
in solving equations with variables on both sides. The thing that's different about this situation is that we didn't eliminate one variable,
We eliminated.
we eliminated both of them. And we ended up with this statement. 0 equals 2. Now, like I said, we talked about this before. When we were solving equations with variables on both sides, we sometimes ended up solving and the variables went away. When you moved it from one side to the other, you ended up with no variables and you ended up with something like this. And what did we say about a case like this?
It is unsolution.
Right, it has no solution.
No solution. No circle.
Because when does 0 equal 2? Never. Okay, if in solving an equation, you get down to a statement that is absolutely never going to be true, like 0 equals 2, then that means there is no possible solution. Okay, a very simple reason why is if you look at the two equations originally, we have y equals 2x plus 1 and y equals 2x plus 3. Well, if y equals 2x, that's a certain amount. If I add 1 to it, and if I take that same 2x and I add 3 to it, are those two amounts ever going to be the same? No. Okay, this is why this has no solution. Or if you look at it on a graph, if I were going to graph this one, I would have one that has a y-intercept of 1 and one that has a y-intercept of 3. And the slope for both of them is going to be 2. So 2 over 1. So I get, I get this line. And then I have this other one with a slope of 2, which is also 2 over 1. Guys,
Miss Nichols.
yes,
When you write like the null set thing, it's like a circle with a line through it. Which way does the line go?
doesn't matter.
Does it?
Yeah.
Can you do like up and down? Can you go like V? Or does that have to be like?
It's diagonally, but whichever way diagonally. All right. Now look at if I graph these. Now, where is the solution to a system if we are graphing it? Tanner, can you go have a seat, please? Now, where is the solution to a system of equations when you're graphing?
It's in the X and Y.
It's where they meet.
It's where they meet. Well, look what these lines are.
They're never gonna meet.
They're parallel lines, meaning they will never meet. Thus, they have no solution, because at no point in time will these lines actually intersect, which means there's not going to be any solution that is on the first line that is also on the second line. So, this would be where you have no solution. Or you can put that symbol. There is no solution to it. All right. So, like I said, not something we looked at specifically, but something that, based on the fact that we'd already solved equations that had variables on both sides where they canceled out, same concept. All right. Any other questions? Tell you what, let's do this. I think we're a little close on time for me to do another one, so